Hello, good morning, students. So, in the last class, we have seen determination of specific gravity by pyknometer test. So, now we will see second experiment of geotechnical engineering lab. I'm sharing the screen with you. I hope it is visible to you. So, the second experiment is determination of specific gravity of solids by density bottle method. So, what it is, we will see in detail now. Experiment number two. Specific gravity of soil solids by density bottle method. So the aim of the experiment is to determine the specific gravity of soil solids by density bottle method. So already we have seen that what do you mean by specific gravity? Specific gravity G is defined as ratio of weight of an equal volume of distilled water at that temperature, both weight taken in air. Or in simple words, how do you define specific gravity? Weight of water to the same weight of water in air. So what is the specification used? IS 2720 part 3 1980. Different specification is used for this method. IS 2720 part 3 1980 is the standard recommendation to determine specific gravity of the fine grained soil. The value ranges are same as the previous experiment. Previous experiment we had determined the value ranges for specific gravity. The same applies here also. The average of the values obtained shall be taken as specific gravity of the soil particle and shall be reported to the nearest zero point zero 0.01 precision. If the two results differ by more than 0.03, the test shall be repeated. So specification IS code is different. IS 2720 part 3 1980 is used here. Whereas in the previous experiment, IS IS 2720 part 4 1985 was used. But the specific gravity ranges remains the same. That is, specific gravity for inorganic soil is from 2.6 and 2.8. Tropical rich iron laterite soil specific gravity is 2.7 and 3. Sand particle composed of quartz have specific gravity of 2.65 to 2.67. Inorganic clay has specific gravity of 2.7 to 2.8. Soil with large mass of organic matter specific gravity is 2.6 and when even it reduces to 2. Now what you have to do, you have to carry out the test and take three readings. If the average of the values of the average of the values obtained shall be taken as the specific gravity of this soil particle and shall be nearest to the zero point zero 0.01 precision. If the two results differ by more than 0.03, the test shall be repeated. This is somewhat precaution type. Now equipment used. The equipment used in the earliest experiment was pycnometer and what you can say pycnometer was used. Pycnometer was used. Apart from that, what was the equipment? Pycnometer about 1 liter capacity, balance equal to 1 gram was used. However, here what are the things which are being used? 50 ml capacity density bottle with stopper. 50 ml capacity density bottle with stopper is used. A constant temperature water bath 27 degrees Celsius. Oven with a range of 105 to 110 degrees Celsius. Vacuum desiccators are used. Vacuum pumps are used. Other accessories such as weighing bands accurate to zero point zero 0.01 gram. Trays, wooden, mallet, etc. Now the specific gravity is calculated using the formula. The specific gravity of soil solids is defined as weight of solids to the weight of equal volume of water. So the expression remains the same. That is G same formula, that is 21 divided by 21 minus 34. That is G is equal to W2 minus W1 divided by W2 minus W1 minus W2 minus W. Now what is W1? W1 is the weight of the bottle. Here in the previous case it was weight of empty pycnometer, but here it is W1 is weight of empty bottle. Similarly, W2 is weight of bottle plus dry soil. and W3 is weight of bottle plus soil plus water, and W4 is weight of bottle plus water. This method is normally used for fine grained soil. Why this method used? This method is normally used for fine grained soil. The method may also be used for medium and coarse grained soil. Apart from fine grained soil, it can be used for coarse grained soil or medium soil also. If the core particles are gained passed through 4.75 MMCU before passing. So what are the precautions you need to take? Soil grains whose specific gravity is to be determined should be completely dry. So similar to the previous experiment, here also what you have to do, the soil grains whose specific gravity is to be determined should be completely dry. If on drying soil lumps are formed, they should be broken to its original size. Normally in soil lumps will be there, you have to break it into its original soil. Inaccuracies in weighing and failure to completely eliminate the entrapped air and the main sources of error both should be avoided. While cleaning the density bottle, please be very careful as there may be glass ring projecting out and it may tear the screen. Make sure you handle the density bottle without falling on your legs or bones. Once handle the equipment with care. So the precautions are similar to the previous experiment again. Now procedure. How you will determine the specific gravity of soil by density bottle method. Clean and dry the density bottle and weigh it along with the stopper. There you weigh, clean and dry the pycnometer and weigh it with cap. But here stopper is there. So how you will first step is clean and dry the density bottle and weigh it along with stopper. That will be W1 in gram. Next, select about 25 gram of dry soil free with calls and put the same into density bottle. Weigh it with brass cap and washer. See here, here also a change is there. In the previous experiment, you took 300 gram of soil, but here how much soil you are taking? Select about 25 gram of dry soil and put the same into the density bottle. Weigh it with brass cap and washable. Fill the density bottle with re-add water up to half its height and stir the mix with a glass rod. So what you have to do, you have to fill the density bottle with de-add water up to half its height and stir the mix with a glass rod. Add more water instead. Place the stopper on top and take the weight W3 gram. Next, what you have to do, remove all the contents from the density bottle, clean it thoroughly and fill it with distilled water. In the next step, what you have to do, you have to remove all the contents from the density bottle. Clean it thoroughly and fill it with distilled water that will be weighed in W4. Now you have to use above equation for determining G. To G, you have to use once again the above equation. Repeat the same process for additional test. So same steps are there, but only the thing is there in place of pyconometer, you are using density bottle, and in place of 300 gram of soil, you can take it 25 gram of soil. So what are the pre-viva question? Which method is accurate in determining specific gravity of soil solids? So if you see here and if you ask me anything specific gravity of soil by pyrometer is more accurate compared to density bottle method. What are the steps involved in determining specific gravity using density bottle? So once again I will repeat it, you just listen it. First what you have to do, you have to clean the density bottle and you have to take and clean the density bottle and you have to dry the density bottle and take the weight of it with the stopper that will be W1 gram. Next, what you have to do, you have to take 25 gram of dry soil, which is free from lumps, and you have to insert it into this density bottle. And again, you have to take it weights. That will be W2 along with brass and cap. In the next step, what you have to do, you have to completely, you have filled the bottle with water up to the top, and you have to weigh it. That will be W3 gram. You have to place the topper on top and take the weight of the bottle. That will be W3. Finally, you have to remove all the things and you have to clean the bottle and fill it with distilled water and again you have to weigh it. That will be W4. Finally, you will determine G using the relation G equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. So what PYO questions? Number 3, how much grams of soil need to be taken for the test? 25 gram. See here in Viva also this question have been asked because it is different to the earlier experiment. In the earlier experiment we took 300 gram of soil, but here we are taking only 25 gram of soil. What is the specification required for the test? IS specification is also different. So what is the specification used? IS 2720 part 3 1980 is used. Next, which is the fourth question. What is the specification required? What is the equation to determine specific gravity of solid? It is nothing but G is equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. Now, if you see weight of density bottle W1 gram, weight of bottle plus dry soil, that will be W2 gram, weight of bottle plus soil plus water W3, weight of bottle plus water W4. So the specific rate is equal to G1 plus G2 plus G3, average of 2. So what is the validation? The value of specific gravity for the existing soil falls in the range of 2.6 to 2.7. If there is any variation, check under the specification provided and read the experiment to get accurate result. So specific gravity ranges from 2.6 to 2.75. So what you have to do, if the value is in between this range, you have to just keep it. If suppose the value is different, what you have to do, the experiment is conducted once again. So the conclusion is the experiment is conducted as per the procedure laid down. The specific gravity of soil solid The specific gravity of soil solid is equal to the value falls in the range 2.6 to 2.15. The type of soil is as per IS specification. So what is the post viva question? Can we use kerosene instead of water to determine specific gravity of soil? See here, if you use kerosene, then different values you may get. There is one more experiment with the help of kerosene. At the time you will do, then you will understand it. Next, second is, could we get to the classification of soil based on the specific variety of soil? Yes, you can classify the soil based on the specific variety of soil, because from the specific variety of soil you will know the type of soil. Could there be entrapped air in the soil sample? Yes, there may be entrapped air in the sample due to voids and all, due to lumps, so it should be removed. What are the various sources of error in this experiment? There are different sources of error in the experiment. There may be a fault in your weighing balance. There may be a fault in your, what you can say, distilled water taken. There may be a fault in your type of soil lumps. Maybe there are some different types of error there. What are the applications in geotechnology with the specific gravity is? See, generally specific gravity is used to determine the, what you can say, whenever you construct a structure. In order to classify the different types of soil, you need to understand what is specific gravity. Because what is specific gravity? It is nothing but weight of solids, soil solids to the weight of in water to the weight of same amount of volume of solids in the air. So once you get the specific gravity, you will be understand, or you will be able to know which type of soil it is. For example, if you see, we get the specific gravity ranges from 2.6 and 2.8. You can call it as inorganic soil. If it is in the range of 2.75 and 3, then it can be called as tropical iron rich laterite soil. If its specific gravity ranges from 2.65 to 2.67, then you can call it as sand particles composed of quartz. If the specific gravity ranges from 2.7 to 2.8, then you can call it as inorganic clays. And if the specific gravity is below as 2.6 and 2, then we can call it as soils with large amount of organic matter. So this completes our second experiment, that is specific gravity on what we can say, using density bottle method. Now we will see experiment number 3, that is known as determination of water content of soil by oven drawing method. So before moving forward, If you have any queries related to the earlier experiment, you can just drop a message in the comment box, or you can even contact me at nathimadhar@kevin.university, or you can just make me a call at 8553 171859. So, experiment number 3, determination of water content of soil solids by oven drawing method. So what is the M experiment? To determine the water content of soil solids by oven drawing method. So how you will define water content? The water content W of a soil sample is equal to mass of water divided by mass of solids. That is MW by MS is your water content. Water content nothing but W, that is equal to ratio of mass of water divided by mass of solids. Small w equal to mw by ms. So specification. This test is done as per IS 2720 part 1. So the specification used for this test IS 2720 part 2 1973. The soil specimen should be representative of the soil mass. The quantity of the specimen taken would depend upon the gradation and the maximum size of the particles. For more than 90% of the particle passing through 424 micron, the minimum quantity is 25 gram. So specification is very important. So which specification you are using for determination of water content? IS 2720 part 2 1973. The soil specimen should be representative of the soil mass. The quantity of specimen taken would depend upon the gradation of the maximum size of the particle. For more than 90% of the particle passing through 425 microns, the minimum quantity is 25 grams. See here how much quantity of what you can say solids you have to take. Soil solids for determining water content. On what factor it depends? It depends upon the particle passing through 425 micron IC. So most of the particle passes through 425 gram micron IC, and as a result of which we take the soil as 25 gram. So what are the equipments used? Equipments required. Slowly we can take it not to wait here. What are the equipment required? Non-corrodable airtight containers, balance weighing to accurately 0.04% of the weight of the soil taken for the test, desiccators with suitable desiccating agent, thermostatically controlled oven with a temperature of 110 degrees Celsius plus or minus 5 degrees Celsius, other accessory. So if you compare this apparatus with the earlier experiment, the apparatus here is more. Earlier we used only picnometer density bottle, but here non-corrodible or non-corrodible, that is, the containers should not be subjected to corrosion. Airtight containers. Next, a balance weighing to accuracy 0.04% of the weight of the soil taken for the so accurate weight balance you have to use digital. Desiccators with suitable desiccating agent. So for oven drawing, you need desiccators or the suitable desiccating agent. Then thermostatically controlled oven. Oven also you should have with which is controlled thermostatically to maintain temperature 110 degrees Celsius plus or minus 5 degrees Celsius. Another accessory. Now theory. In almost all soil tests, natural moisture content of the soil is determined. The knowledge of the natural moisture content is essential in all the studies of soil mechanics. To cite a view, natural moisture content is used in determining the bearing capacity in settlement. So what is the need of determining the water content or water content of soil? Because in almost all the cases, it is essential to determine the water content to determine the bearing capacity and settlement. The natural moisture content will give an idea of the state of the soil in the field. So why this test is conducted? It will give how the soil it is. Idea to a structural engineer how the soil it is, how much load it can bear. Water content W of a soil mass is defined as ratio of mass of water in the what's to the mass of solids. So as I said you, what is water content? Mass of water to the mass of solids. So what is the equation used for determining your water content? Small w equal to W2 minus W3 divided by W3 minus W1 into 100%. In terms of percentage, we are determining the water content. So W1 is weight of empty container in grams. W2 is weight of container plus wet soil in grams, and W3 is weight of container plus dry soil in grams. So W1 is here also same, it is the weight of empty container in grams. But W2 is changing weight of container plus wet soil in grams. Here it was there was weight of container plus dry soil. And W3 is weight of container plus dry soil. So what are the precautions you have to take while doing this test? Ensure that the soil samples are below between 350 to 400 gram. Larger samples take too long to dry while smaller samples lead to inaccurate result. So what you have to do whenever you perform this test, soil you have to take. So don't take too much amount of soil. It should be in the range to 350 to 400 gram only. Because if you take large sample, you have to dry it, so it will take more time. Ensure that the oven temperature is maintained 110 degrees Celsius plus or minus 5. Do not allow the oven dry to stop open for long, too long, as it takes oil further or for in the drying temperature. Temperature and oven maintenance should be monitored carefully. Do not put moist sample in the oven on a shelf below dry sample. Moist sample should be placed on the top shelf and all the particularly dry sample placed on the lower shelf. So in the oven, the moist sample should be placed on the top shelf. And the dried sample should be placed on the lower shelf, similar to a refrigerator. Do not overload on the oven, as this will create much longer drying time. Do not overload the oven. In other sense, do not put much amount of soil in, because it will overload the oven. Do not allow dried sample to pick up moisture after they are removed from the oven. Weigh them immediately after drying. See here, we are keeping in oven to dry the sample. So as soon as you remove the sample, you have to perform the test, or else it will again regain moisture. Soils and aggregates may contain bacteria and organisms which can be harmful for oneself. Wearing dust masks and protective gloves when handling material advice. The use of heat resistant gloves or foot holder to remove samples from the owns is recommended. See here, post COVID, you have to take many measures. So normally we are wearing the mask and all. Gloves also you should wear, because these soil particles may contain some bacteria which is injurious to health. Prior to handling oil testing and disposing of any waste material, students are required to read and produce GDP liberty. So do's and don'ts we have already read. So what is the procedure? How this test is performed? Clean the container with the lid and find the mass W in gram. So similarly, how you are performing the test? You are cleaning the container with lid and find the mass, that will be W1 gram. Next, select the required quantity of moist soil, place it container, place the lid and weigh it. See here, in the second bit, we are not defining how much amount of weight you have to take it. It may differ, so we are telling select the required quantity of moist soil sample. Place it container, place the lid and weight that will be W2 gram. Keep the container in the oven with lid removed and dried for at least at temperature 100 degrees Celsius till the mass becomes constant. Remove the container from the oven, replace the lid and cool it in the together. Find the mass M3. So M3 is W3 is changing. W1 is same, that is weight of empty container. W2 is also same, container plus weight of soil, but there it was dry soil, here it is moist soil. W3, what you are doing, you are taking keeping the container with soil in the oven, drying it, and then calculating its weight, that will cooling it, then you are calculating the weight W3. Determine the water content W using the above equation. So repeat the experiment with other test sample. So what is the equation? Equation is very simple, that is W2 minus small w is equal to W2 minus W3 divided by W3 minus W1 into 100. So repeat the experiment with other samples. So what are the pre-viva question? Water content is also called uh, natural content. Which method is mostly used to determine the water content in fuel? This is using what you can say density bottle method. The own drying method is mostly used for determining water content as well. What is water content for clay soil? So this you need to just search it on net. On which factor water content depends? Water content depends on the soil properties. Ground penetrating radar method is also used for measuring water content. True, false? No, false. Name different types of soil textures. Kaolinite, montamonite, also different types of soil textures available. The disperse and all. The percentage of water remaining in a dry soil is called water content. So tabular column is there. What is W1? Weight of empty container. W2, weight of container plus wet soil. W3, weight of container plus dry soil. Small w. The average W is equal to W1 plus W2 plus W3 into, average it is. So specimen calculation, small w is W2 minus W3 divided by W3 minus W 100%. Average is there. So what is the validation? Soil mass is generally in a three-phase system. It consists of soil particle, liquid and gas. This already have studies in geotechnical. It is soil consists of three-phase system. It consists of solid particle, liquid and gas. The phase system may be expressed either in terms of mass, volume, or weight volume relation. Water content value is 0% for dry soil, it is magnetic accident 100%. In dry soil, only two phases are there. So, what is the conclusion? The experiment is conducted as per the procedure laid down. The water content of the soil sample is determined. Water content W is equal to this much percent. The value is verified and the three phase system is sketched. So what are the post-bio question? Draw the symmetric diagram of three system based on the result. So that is nothing but three-phase system to define raw containing water, air, and gas. Is there a possibility of the soil getting burnt? In that case, what will the effect of water content? No, there are rare cases in case of the oven drinks, oven may getting a bursting out. How does air dry soil differ from oven dry soil? Air dry soil contains air voids and water, whereas oven dry soil is completely from all that. Is this method most accurate when compute water content of soil? That needs to be checked. You cannot say it now. To get accurate is the how much gram of soil have you taken to conduct the test. See here, how much gram of soil you have to take for the test. That again you have to go to specification, which says this test is done as per IS 2720 Part 2 1973. The soil specimen should be representative of the soil sample. The quantity of the specimen taken or depend upon the gradation and the maximum size of the particle. For more than 90% of the particle passing through 4.425 micron sheet, the minimum quantity is 25 gram. So if you take 25 gram of soil, then you can get more accurate results. So I hope you have understood the experiment. Once again, I am just doing a recap of it. So just listen it. So the aim of our experiment is to determine the water content of soil solids by oven drying method. So how we are defining water content? Water content is nothing but mass of soil solids in water to the mass of soil solids in mass of water divided by mass of solid. So which IS code is used for this method? This test IS 2720 part 2 1973. And how much is the quantity of soil to be taken? 25 gram. So what are the apparatus required? Airtight container which are free from corrosion, balance weighing accurately to 0.04% of the weight of the soil sample taken, desiccator with suitable desiccating agent. Next, thermostatically controlled oven maintained at 110 degrees Celsius plus or minus 5 degrees Celsius. Other accessories. So, how you will calculate water content? W is equal to W2 minus W3 divided by W3 minus W1 into 100%. So, W1 is the weight of empty container, W2 is the weight of container plus wet soil, W3 is the weight of container plus dry soil after drying it in oven and cooling in it desiccator. So how you will perform the test? First W1 weight of empty container, next empty container. After that, you have to take 25 gram of soil. Uh, then you have to wait that will be W2. After that, you have to keep this setup in the oven at 110 degrees Celsius. After that, you have to cool it. Again, you have to take the weight W3. Repeat the experiment. And finally, you will get the answer for water content. That is weight of empty container W1 gram, weight of container plus wet soil W2 gram, weight of container plus wet soil W3 gram. So your W small w equal to W2 minus W3 divided by W3 minus W1 into 100%. So water content is also known as your natural content. So this so after that, what you have to do, you have to represent soil as a three-phase system which contains of water, air, and solids. So the experiment is conducted as per the procedure laid down. The water content of the soil sample is determined. Water content is equal to W percentage. The value is verified and a three-phase system is scaled. So this experiment is very simple and easy, and it is also very important test in order to determine the bearing capacity of soil settlement of soil. Based on the water content values also, you can classify the soil into different types. So it is a very important test. So if you have any doubts related to the experiment, you can just drop a message in the comment box, and also you can contact me at nariman@kevin.university, and also you can just call me at 8553 171859. So this completes our second experiment. In the next class, third experiment, sorry. In the next class, we will see determination of water content by pipetometer method. So I hope you have a good day. Thank you, friends. So I'm stop sharing the screen. So if you have any queries related to geotechnical engineering lab, you just feel free to ask me. I hope you have a good day. Thank you, one and all.